up to 11.3. Measures of association. So we know we perform a chi-squared test, we get a chi-squared test statistic, and the larger the chi-squared test statistic, the smaller the p-value, and you would simply reject the norm. But a larger chi-squared statistic does not imply stronger association. All we can say is that they are connected, they are associated if we reject the norm. Just because I have a chi-squared value of 69.68 in the previous example does not imply that the association that we saw was really, really strong. So the size of chi-squared statistic has nothing to do with the strength of association. So how do we determine, or how do we measure the strength of association? The first one is proportion differences, or difference of proportions. We have two groups, we just want to find the difference between P1 and P2, and we just subtract the differences. Number two, relative risk. Let me just use notation here. So P1 minus P2, two proportions, difference of proportions, relative risk, P1 divided by P2. And the last one is odds ratio. If we want to know about odds ratio, we've got to know what odds are. Yes. Now, suppose you play a game and the probability that you win is 1 in 50. Or let's say 1 in 30, let's put it that way. So how many times do you win for every 50 times that you lose? 1, right? So in total, you have 1 over 50, that is winning. So the complement of that would be losing, right? So 1 over 50 is the chance that you win. 1 minus 1 over 50 would be 49 over 50, correct? These 50s will get cancelled. So 1 is to, that column means is to 49. And that is what we call odds. Yes. So the odds of winning is 1 to 49. So if you play 50 times, you will win once and lose 49 times. Does that make sense? If you go to Las Vegas, they're not going to use the fancy term probability. It should be of this sort, the odds of winning the game. So how did we find this? This is simply the ratio of probability of winning, I'll call it P, divided by its complement, which is 1 minus P. Agreed. The is to sign, which is a ratio notation, is the same as a fraction P over 1 minus P. So P in my case is 1 over 50. 1 minus P is 49 over 50. Fraction over fraction, what do we do? Algebra. How do you simplify? Thomas, right? How do you simplify? Great answer, simplify, but how? Fraction over fraction.
Don't we like multiply them, but then put 50 over 49?
Very good. Flip and multiply. So 1 over 50 multiplied by 50 over 49. The odds would be 1 over 49. Yes? 1 over 49 is the same as saying 1 is to 49. Right? So the way we interpret odds when it's written that way is simply 1 over 49. For every, if you played for 50 times, you'll win once and you lose 49 times. Does that make sense? So what is odds ratio? Odds ratio is simply the odds of the first group divided by the odds of the second group. Good. Odds in general is simply P divided by 1 minus P. And odds ratio is simply the odds of the first group divided by the odds of the second group. Yes? So each of those will give us a measure of association, but do keep in mind, you will not come to this step if you do not reject the norm. We only come here if we find an effect, if we find significance in rejecting the norm. So this is what we call post hoc analysis, in the sense you perform a test. After you perform a test, you are assessing how strong the association is. So you reject the null in a chi-square test for independence. You determine that things are related to each other. Once you come to that conclusion, we want to say how strong it is. Good. Now, that part's easy. Can I erase this? Difference in proportions. If both of them are the same, that wouldn't make any sense, because if the proportions were the same, the test for independence would not have rejected the null. Do you agree? So clearly there has to be a difference. If P1 is significantly bigger than P2, you would get a positive number. If P2 is bigger than P1, you get a negative number. Yes. So, and both of them are probabilities, and we know probability cannot exceed 1. So this difference will always be between -1 and +1. Theoretically speaking, if you have the strongest association possible, and if it is ideal, then you would either get 1 or -1. In practice, it will never happen. You can get closer to 1 or get closer to -1. Does that make sense? So the closer you are to 1 or -1, the stronger the association. Does that make sense? Yes. Case 2, relative risk. If both of them are the same, what would you get? If P1 and P2 are the same, then what is P1 over P2? 1. A relative risk of 1 simply means that there is no association whatsoever. Does that make sense? 0 up to 1 and 1 up to infinity. It can go all the way up to infinity. But typically we don't go past 10. You know, it doesn't make any sense to go past 10. I believe your book stops at 10 also. Between 0 and 1 means that the denominator has to be bigger than the numerator. Yes? So P2 is bigger than P1. Over here, P1 is bigger than P2. So if you go far from 1, stronger association. Same, if you get closer to 0, you have stronger association. Bigger than 1, stronger the association as it gets bigger and bigger. But in practice, beyond a certain point, it's meaningless to specify the primitive bits. Odds ratio will follow the same pattern. And an odds ratio of 1 would indicate that there is no relationship. Of course, that would be supported by the test. We don't even have to find the odds ratio. Chi-square test will not reject the norm. So we come to this step if we reject the norm. So larger the odds ratio, stronger the association. Closer to 0, stronger association. But just in the other direction. Does that make sense? I'll show you how to interpret these with an example, or do an example. Good.